Hey everyone, so I'm going to do your review for your test on Thursday. This is all from mean value theorem up to optimization. So let's get started. The first question I'm going to change. I'm not going to do this one. This one's a little difficult. So I'm going to change it to y equals negative x cubed plus 4x squared minus 3 on the interval of 0 to 4. Okay, so the first question says find the value of c that satisfies the mean value theorem. So the mean value theorem states that there is some point c that'll make the slope equivalent to the slope of 2 points on a line. So the average rate of change is the right side and the derivative is on the left side. So the first thing you want to really do is find the derivative of your function. So I'm going to find the derivative of this and get negative 3x squared plus 8x. And then what I'm going to do is I'm going to plug in, this is a and this is b, so I'm going to have 4 minus 0 on the bottom, and then I'm going to do f of 4 minus f of 0 on the top. So I'm going to have to plug in to the function to get those values. So f of 4, what I'm going to do is I'm going to plug in 4 into the function. So it'll be negative 4 cubed plus 4 times 4 squared minus 3. When you do that, you're going to get negative 64 plus 64 minus 3. And that gets you negative 3. So right now I have negative 3 minus all over 4 equals negative 3x squared plus 8x. And I'm going to do f of 0 now. I'm going to plug that into my original. So negative 0 cubed plus 4 times 0 squared minus 3, that's going to get you negative 3 again. So I have negative 3 minus minus 3. So now what I have is, well, this becomes a positive, and that becomes 0 over 4, which ultimately is just 0. And that's equal to negative 3x squared plus 8x. And what you really just have to do right now is solve for x, and I'm going to take a GCF out, and I get negative 3x plus 8. I'm going to split this to get x equals 0 and x equals negative 8 over negative 3, so x equals 8 over 3. Now the thing you have to make sure about the mean value theorem is that your answer is inside your interval. Inside, not with the brackets. So you want to make sure your answer, your c value, so both of these would be c values, but we're not going to use this one because that is on the endpoint. Basically, for the mean value theorem to work, it has to be on the inside of the interval. So the answer for c that we're looking for is c equals 8 over 3. The next question says, given the following graph of f of x, so this is the graph of f of x, state the intervals where the graph of f prime of x satisfies that f prime of x is greater than 0 and f prime of x is less than 0. Now this is having to do with the whole increasing and decreasing scenario. This is the actual graph. So on the graph, I am increasing here, and I am decreasing here, and I'm decreasing here, which means that the output of the first derivative would be negative here, and it would be positive here. So therefore, the first derivative tells you the slope of the function. So I know my first derivative is positive between, this looks about negative 5 and this looks about 5, so between negative 5 and 5, positive meaning greater than 0, so like on the number line you'd have negative 5 and 5, and this would be positive meaning that you're increasing. And then I'm less than 0, negative infinity, so I'll do this in red, negative infinity to negative 5, and then also from 5 to positive infinity. So that means that my first derivative's number line would have a negative here, and I'd be decreasing and decreasing. So this is your answer here. So I am my derivative is greater than 0 between the areas where I'm increasing on the graph, and I am my first derivative is less than 0 when my values are decreasing on my actual graph.
This question says, use the first derivative test to determine the local extrema if any of the function fx equals 3x to the fourth minus 6x squared plus 7. The first derivative test is just taking the derivative of the function, and this one would be 12x cubed minus 12x. Setting it equal to 0, finding your critical points by factoring. So I'm going to pull out a GCF. So my critical points are going to be x equals 0, x equals 1, and x equals negative 1 because this is dots, x plus 1, x minus 1. What you're going to do is plot those critical points on a number line. So negative 1 goes here, 0 goes in the middle, 1 goes over there. And this is the number line of f prime. So what you want to do is test all your values into f prime, which is your derivative. And I'm going to test f of negative 2. And then I'm going to also test f of negative 0.5. Oh, f prime, I'm sorry. So make sure you're plugging it into this derivative. So f prime of 0.5, the positive 0.5, and then also f prime of 2. So I just picked values in each interval, and I want to see if they're positive or negative. When I plug in f prime of negative 2 into my derivative up here, I get negative 72, which gets me a negative value. When I plug in negative 0.5, I get 4.5, which is positive. So when I plug in 0.5, I get negative 4.5, which is negative. And then when I get 2, I get a positive 72, which is positive. Basically, my graph would look something like decreasing, increasing, decreasing, and increasing. So the question asked, use the first derivative test to determine local extrema. So I would have a local max, which is the same thing as relative max, by the way. I would have a local max at 0. Remember, this is going on to infinity because this interval is not closed, so it's just at 0. And then I would have a local min at x equals negative 1 and at x equals 1. And that's that. Next question says find the inflection point. Inflection point is the second derivative. So what I want to do first is obviously find the first derivative. And I'm going to do that by bringing down the 4. So I have 4 over 4, x to the third, because you subtract by a power of 1, minus 3x squared, and that 6 becomes a 0. Now I'm going to take the second derivative. By the way, this just cancels out to 1. So really I have x cubed minus 3x squared for my first derivative. But for my second derivative, I'm going to take the derivative of the derivative. So the derivative of the derivative is 3x squared minus 6x. And to find my point of inflection, I'm going to set this equal to 0 and factor. So I'm going to pull out a 3x, and I'm going to be left with x minus 2. So I have a point of inflection at x equals 0 and a point of inflection at x equals 2. So those are where my points of inflection are. All right, the next question says a carpenter is building a rectangular room with a fixed perimeter of 140 feet. So I know my perimeter is 140 feet. What are the dimensions of the largest room that can be built, and what is its area? Well, perimeter is talking about all the sides added up. So my perimeter is really equivalent to 2x plus 2y equals 140. And then they want you to find out the dimensions of the largest room that can be built. So length times width. And then they ask for the area, which kind of helps you out because you know you're going to end up using the area formula equals x times y. The one that you're going to solve for a variable and the one that you're going to take a derivative of is different. And basically the one that you're going to take the derivative of is the one that has no number in it. So it's not equal to a number at all. So I'm going to take the derivative of the area just to find the maximum area that this could be for the room. And then what I want to do in order to take the derivative of the area is I want to make sure that it is in one variable, and that's where the first equation comes into play. So the first equation, what I'm going to do is I'm going to solve for a variable. I'm going to choose to solve for y, so I'm going to subtract 2x, and I'm going to get 2y equals 140 minus 2x, divide by 2 on everything. So y equals 70 minus x. And that's what I'm going to put in for y right here. So I have area equals x times 70 minus x. I'm going to distribute this in, so I get area equals 70x minus x squared, and this is where I'm going to go ahead and take my derivative. I'm going to take my derivative so that I can find that local maximum, basically where there is a maximum on the graph, therefore where I'm going to get my maximum area. And that's going to give me the x value from a maximum area, which is the width in our case. So what I'm going to do is I'm going to take the derivative and I'm going to get 70 minus 2x. And then I'm going to set it equal to 0 to find that critical point that gives me my maximum area. So basically the width that gives me my maximum area. I'm going to solve for x, and I get 2x equals 70. So 2 divided by 2, x equals 35. And just make sure you guys are reading the question and seeing what it's asking for. It's saying, what are the dimensions? So I know my width is 35. My length, I'm just going to plug that into the y formula. And 70 minus 35 gets you 35 again. So my length is 35. So obviously we have a square. So I have my length is 35, my width is 35, and they want the area, the maximum area. So the area of this thing, basically just multiply your dimensions, 35 times 35, and that gets you 125 feet squared. And another tidbit, I should have probably labeled these feet. So let me just put that in there. The next question says, use the mean value theorem to find the value of c on the ultimate interval from a to b for the following. So again, for the mean value theorem, you need the derivative at some c value equals the average rate of change on the closed interval of a to b. So I'm going to plug this in again. So I have a and I have b. So it'd be 3 minus 2, that's 5 on the bottom. And I'm going to do f of 3 minus f of negative 2. Okay, so I'm going to work with the right side first and get that f of 3 and that f of negative 2. I'm going to basically get f of 3 by plugging into the original. So negative 2 times 3 plus 6 all to the 1/2. That gets you 0. So I have 0 here minus. And then when I plug in f of negative 2 in for my next part, it's a little tricky. I'm going to do this actually in pieces. So basically what I get here is negative. This becomes a 4. 4 plus 6 is 10. It's the 1/2. And basically we all know that's not going to reduce nicely. So I'm just going to leave this as negative radical 10. And that's what I'm going to put in here. So negative radical 10. So now I'm going to go ahead and take my derivative of my original function. And this derivative is a little tricky, but you're going to use the chain rule, bring down the 1/2, negative 1/2, parentheses negative 2x plus 6, keep the inside. Subtract 1, so you get negative 1/2 as your exponent. And then take the derivative of the inside, which is negative 2. Now what you're going to do is you're going to reduce. So the 2's would cancel. A negative and a negative make a positive, so those go away. And I'm left with negative 2x plus 6 to the negative 1/2. I'm just going to clean this up a bit. My right side of my equation, this becomes positive radical 10 over 5. And then this side here is a little different if you want to write it. And it's actually better to write like this. I'm going to do 1 over the square root. It's a square root because it's a 1/2 power. It's now in the denominator because it's a negative exponent. Negative 2x plus 6. And now I'm going to cross multiply. I'm going to get 5 equals, when you have a radical and a radical, you just multiply the insides. Hopefully you guys remember that. And now what I'm going to do is I'm going to take the square root of both sides to cancel out the radical. And I get 25 equals, I'm going to distribute the 10 in, so negative 20x plus 60. Subtract 60. When I subtract that, I get a negative 35 equals negative 20x. Divide by negative 20, divide by negative 20. So x, when it gets reduced, is 7 over 4. Just make sure that 7 over 4 is inside your closed interval of negative 2 comma 3. And it is, so this is your answer. And actually, we should label this C, not X, because that's what you're looking for. Okay, so this question says, at what coordinate does the function have absolute extrema, if any, exist over the given interval? Now, what's really important to realize is that they're asking for absolute extrema, which is different than relative extrema. basically what you want to be careful of with absolute extrema is that the endpoints could only be considered as absolute. In this case, it is a closed interval, so you're going to have to test the endpoints to see if they are absolute. Remember that the endpoints cannot be relative extrema, they can only be absolute extrema. And basically what we want to do is we want to find the derivative of this thing so that we can find our critical point, so that we can test values, so that we can see where we have a max and a min, therefore having your absolute extrema. So I'm going to first take my derivative, so 4x cubed minus 6x, and I'm set that equal to 0, and I'm going to take the GCF out, and basically I'm going to factor to find my critical point. So I'm going to take out the GCF of 2x, and I'm going to be left with 2x squared minus 3. Split this, I get x equals 0, and I get 2x squared equals 3, divide by 2, x squared equals 3 over 2, take the square root, x equals plus or minus, this comes out to around 1.225. I'm going to completely ignore this critical point, and the reason why I'm going to completely ignore that critical point is because it's plus and minus 1.2, and that is not in my interval, it's actually outside my interval, so I get to ignore it, which is great. The only point I'm going to put on here is 0. And this is the number line again of my derivative, so all my points that I test are going to be plugged into my derivative. So I'm going to test negative 0.5 because that's between negative 1 and 0. I'm going to plug that into my derivative, and that gets me a positive 2.5. And that gets me positive here, and then when I plug in f prime of positive 0.5, that gets me negative 2.5, which is a negative. So I know I have a max at 0. So basically I want the coordinate. I also need to test my endpoint. So what I'm going to do is I'm going to put negative 1 comma something, I'm going to put 0 comma something, and I'm going to put 1 comma something. And those comma somethings are going to come from the original. So what I'm going to do is I'm going to plug in these x values to get my y values from the original. So I'm going to plug in f of negative 1, and that's going to give me 2. So this coordinate point is 2. I'm going to get f of 0, and that gets me 4. And then when I plug in f of 1, that also gets me 2, which is kind of interesting because these two values are the same value of a minimum. So what I'm going to say is I have an absolute max at 0, 4, because that's obviously the highest y value. And then I also have two absolute mins because they're at the same level. My absolute min happens at negative 1, 2, and 1, 2. Obviously, if one was lower, you would say that was the absolute min, but because they're both the same y values, they are both considered absolute mins. The next question has a few parts. It's basically asking you to investigate a function by just using calculus. So just to answer the parts that it's asking for part A, it says, over which intervals is the function increasing or decreasing? Well, that has to do with the first derivative. So the first thing you should do is take the first derivative, and you get 3x squared minus 6x minus 9. And to find out where you're increasing and decreasing, basically you want to find your critical points. And to do that, you're going to set this equal to 0, and you're going to factor. So I'm going to take out a GCF of 3. And then I'm going to factor using trinomials. So it's different signs, and 3 and 1. X equals negative 1 and x equals 3 are your critical points, and those are the values that are going to go inside your number line. And this is going to be the number line of f prime. So when you test values, just make sure you're testing it inside of f prime. So what I'm going to do is I'm going to test f prime of negative 2. And when I do that, I get a positive 15. So I get positive. And again, I'm plugging it into my derivative. That's how I got 15. And then I'm going to plug in 0. When I get that, I get negative 9, which is negative. And then I'm going to plug in f prime of, let's say, 4. And that gets me positive 15 again, so I have positive here. So my function is increasing here, it's decreasing here, and it's increasing here. So the interval that I'm increasing would be from negative infinity to negative 1, and from 3 to infinity. And where I'm decreasing would be from negative 1 to 3. So that's the first part. Now the second part says, where does f of x, or where does the function have any relative extrema? And basically you can use the part A that you just did to find that. Well, you should know that I have a relative max and a relative min. just look at the sketch that you created. Here would be a relative max, so at -1 is your relative max, and then your min would be right here, so at 3 is your relative min. So then the next part states where does the function have points of inflection. To find points of inflection, all you're going to do is you're going to take the derivative of the first derivative, hence you're taking the second derivative. So I'm going to look at this guy here and take the derivative of him, and that'll give me my second derivative, and my second derivative will become 6x minus 6. To find my points of inflection, I'm going to just set that equal to 0, and I'm going to factor by taking out a 6, and I'm going to get my points of inflection as x equals 1. The 6 means nothing because you know that 6 can't ever equal 0. That cannot ever happen. So I have a point of inflection at x equals 1. And again, remember, a point of inflection is where your concavity is going to change. Hence, the second part of this question, or the last part of this question, part D, says where's your concavity? Where's your concave up? Where's the concave down? So what you're going to do is you're going to plot your point of inflection on your double prime, your second derivative's number line. And you're going to now plug this into the second derivative. So I'm going to pick a test point on the left, and the test point I'm going to pick is 0. And I'm going to plug in that 0 into my second derivative, so I'm going to plug it into here. And what I'm going to do is I'm going to get 6 times 0 is 0, and then you get -6, so that's negative. And then I'm going to plug in 2 as well, because that's on the right side of 1. And when I plug in 2 into my second derivative, I'm going to get 6, which is positive, so I know that I'm concave down, because it's sad face, concave up. So I would say concave down from -infinity to 1, and then I would say concave up from 1 to infinity. The next question says, use the second derivative test to find the local extrema of. Now the second derivative test is not terrible. All you have to do is first you find the first derivative. Let me just name it f prime. The first derivative of this thing is 3x squared plus 12x minus 36. And what you're going to do first is you find the first derivative, then set it equal to 0, and find your critical point. I'm going to take a GCF out, and I'm going to be left with x squared plus 4x minus 12 equals 0. And then what I'm going to do is I am going to factor this. I'm going to get plus minus 6 and 2. So x equals -6 and x equals 2 are your critical points. And what you're going to do now is you're going to take the second derivative, and that's your second step. So second derivative of x is going to be 6x plus 12. And what you want to do with this is you're going to plug in the critical points that you just found. So I'm going to plug in -6. When I plug in -6, I get a -24. That negative for the second derivative represents a concave downward concavity, meaning that at x equals -6, there is a relative max, or a local max, however you want to say it. In this question, they say local extrema, so I guess I should really say local, but relative and local is the same thing. The reason why it is a max is because it's a concave downward graph. Then I'm going to plug in f double prime of 2, so 6 times 2 plus 12, that gets me 24, which means I am positive, which means I'm concave up, which tells me at x equals 2, there is a relative min, or a local min, however you want to state it. The next question says, engineers are designing a box-shaped aquarium with a square bottom and an open top. So with these types of problems, always draw yourself a sketch. You have a box-shaped aquarium with an open top. So usually what I do is I shade in the top because I know that I'm not using it. It says the aquarium must hold 500 feet cubed of water. Well, feet cubed and holding water tells you automatically you're dealing with volume. And the volume of a rectangular prism would be length times width times height. I'm going to take away the units just for now. So I have length times width times height equals 500. And it says, what should the dimensions be to create the aquarium with the least amount of glass? So they also tell you in this thing that it has a square bottom, which is very important. That'll help you out a lot. So let me label the bottom as x and x, and I'm going to label the height as h. So that makes my volume x times h equals 500, which helps me out even more because I got x squared plus h equals 500. All right. Now, they want the least amount of glass to be used. They're talking about surface area essentially because that's the areas of all the glasses, pieces of glass that make up the aquarium. So what we want is to find the formula for each area of this figure, this three-dimensional figure. The area of the bottom is x times x, which is just x squared. There's no top to it, so there's not a piece above it that has that. Now this side one is x times h. So I'm going to add x times h. And then this side one's also x times h because that's the height. So plus xh again. And then this backward one is also x times h. So I got x times h again. And this side one here is also x times h. So I have 1, 2, 3, 4 x times h's. So my surface area's formula is x squared plus 4xh. Now, the one that I'm going to take the derivative of is the one without the number it's equal to. So I'm going to take the derivative of surface area. But first I need to get into one variable to do that. So I'm going to solve for h squared, to solve for h in this one. So I get h equals 500 over x squared. And I'm going to plug in for h over here. Now, your goal is to take the derivative, but it might be best to reduce a little bit. I'm going to cross out the x and cross out that squared. So right now my surface area formula is x squared plus 4 times 500 over x. I'm going to go ahead further and multiply the 4 times the 500. Gets you 2,000 over x. And usually what I do to make the process of getting my derivative easier is I'm going to make this 2,000 times x to the negative first, which is just bringing that x to the first up. Now I can take my derivative, so I get 2x minus 2,000. The reason why I get minus 2,000 is because I brought that down, x to the negative second, because I subtracted 1 from the exponent. Now my surface area prime is equal to 2x minus 2,000 over x squared. Now basically to minimize, you want the minimum, the local minimum, which again is your derivative, which hence you need your critical point. So to find your critical point, you're going to set this equal to 0 and solve for x. You're probably going to need a common denominator, so to get a common denominator, I'm going to multiply this and this by x squared. So now I have 0 equals 2x cubed over x squared all over x squared. So hold on. I'm just going to put this all over x squared minus 2,000. You could cross multiply if you want. Basically, all you need to worry about is the numerator because the denominator of x squared just is going to become 0. So I got this. I'm going to add 2,000. Let's get 2,000. Oh, too many zeros. Equals 2x cubed, divide by 2. So I get x cubed equals 1,000. I'm going to take the cube root, and we all know that the cube root of 1,000 is 10. So the question's asking you to find the dimensions in order to create an acceptable aquarium with the least amount of glass. Again, your picture looks like this. Your bottom is square, so x by x. So my width is 10 and my length is 10. You just need to worry about getting your height. And your height is going to come from that formula that you found all the way up here, the 500 over x squared. So to get my height, what I'm going to do is I'm going to do 500 over 10 squared. That'll be 500 over 100, and that gets you 5. So my length, my width, and my height are now found. So I know that my aquarium is 10 feet by 10 feet by 5 feet. And there you go. I hope this video helped. If you have any other questions, please come to Extra Help. But otherwise, I'll see you guys tomorrow.